Okay, so the variance and standard deviation are what we're going to talk about next. We're not going to go through this example right now. We likely will do it at the beginning of class for this because I do want you to know where it comes from, but I don't want to take the time to do it. So variance, the symbol for it is S squared for a sample, or sigma squared for a population. To be honest, the variance is not used hardly ever, and what it stands for, the standard deviation, I can tell you what it stands for. The variance is very hard to explain what it stands for. It's essentially the square of the standard deviation is the best explanation I can have. Here's the formula for it. If you ever see that on formula sheets, you'll notice X bar is in the formula. There's a summation. We'll talk about that when we do this example because we'll find the variance on the way to finding the standard deviation. But you'll notice it uses X bar in the formula, which is why the variance is not resistant, because X bar is not, because the mean is not. The standard deviation, the definition of this is the average. The standard deviation is the average distance each data point is away from the mean. Okay, so obviously the variance is the square of that, so it's not the average distance because the distance formula has a square root in it. It's the square of the distance? I don't know. So that's what, anyway. The formula for this, or the symbol for this, same as the variance, only it's the square root of it. So it's S for a sample and sigma for a population. You'll also see me sometimes write it as SD, just to be clear that that's what it is, because S sometimes looks weird. The formula for that is just the square root of the formula for the variance. Sometimes you'll see this with an n in the denominator instead of n minus 1. That has to do with the degrees of freedom, and the whole population sample thing, but we will use n minus 1. And we already talked about what's resistant. So because of what's resistant, for a symmetric distribution, you will report the standard deviation. And here's where I'm going to abbreviate it, SD. Because it's not going to be the same as the interquartile range, but because for a symmetric distribution, the mean is a better measure of center, the standard deviation is also a better measure of spread. All right, so typically when you're describing your distribution, you're either going to go mean standard deviation or median IQR. And again, that makes sense because you use the mean to find the standard deviation. There's that mean. And for the IQR, the quartiles are very, very similar to the median. The median is a quartile, so it makes sense to do that. Okay, so we're going to go back and we're going to describe the distributions that we did back here. We're going to describe this one. So we're going to cuss about it. We're going to say the distribution. Usually I actually do shape first. So the distribution of agility, you want to bring in the context. So you kind of your 5 W's, but we don't have to do the 5 W's. So the distribution of agility test scores, we'll say, of 4th graders. Now, we want to describe the shape. I would say, I mean, this is definitely not perfectly symmetric, but I would say it's fairly symmetric. I don't see like a tail necessarily, so it doesn't have to be perfect. Sometimes there's more than one answer to what the shape could be, to be honest. So we're going to say it's definitely unimodal and symmetric, or you could say roughly symmetric if you want to give a little wiggle room to your answer. Then we want to say the measure of center. So ideally, I would actually calculate the mean, but I don't want to take the time to do that because these videos get so long. So I'm going to say the mean score is blah. and we ideally calculate it. You want a number here though. You don't want a range of numbers, you want a number. So if I had written these in, I could, at least from the graph, make a guess as to the middle of what this is. I didn't write them all in, although it looks like they go by threes. So if this was 18 to 21 and this was 21 to 24, I could say the mean score, if I was just guessing anyway, would be 22.5. All right, but since we have the data, you could actually find the mean on your calculator. The standard deviation is blah, and that I just can't even guess from this. I have no idea what the standard deviation would be. Standard deviation is very hard to make a guess about. But again, you could calculate that because you have the data. So when you are doing this on the AP exam, you need to give a number. Even if it's a guess, you need to give a number, okay? And you want to say anything unusual. In our case, there aren't any outliers or gaps, so we just say there are no outliers. You could say no outliers or gaps if you'd rather. All right, let's look at this one. Now, for shape on this one, if we had this stem and leaf plot, you might almost say uniform, because I think if you line these numbers up perfectly, these are all uniform, and then you have this weirdo here. But if you look at this one is actually fairly symmetric. Again, we're not going to have a skewed one. I just don't have one. So we would say the distribution, I just don't have an example of that, of pulse rates for women is unimodal. Now the peak is not in the middle, so I don't know. Let me look at what I originally had here. We said skewed to the left the last time I did this because the peak is, like if you turn it to the side, the peak is on the high end. So we'll say skewed to the left just to have one that's skewed. All right, so if it's skewed, we're going to report the median. So we'd say the median is, and then we'd want to actually find it. All right, so if I count to the middle, let me see if I can do that real quick. And this is why having them be, oh, it's going to be 72. It's in that 2 somewhere. The median is 72, and if you know the units, you want to use them. So beats per minute. The IQR is, and again, you could find the quartiles. You could use your calculator to find them. I'm going to say maybe my quartiles are probably 64 to 80. So that's what, 16? Yeah, so it is about 16 beats per minute. And again, on this, I don't necessarily think there are any outliers. You could actually calculate the fences, though, since you have the IQR. Let me see what I originally put, because I'm not looking at it. I'm going to say there are no outliers because nothing sticks out to me. But you could actually calculate it. I'm just being a little bit lazy because I know I have one more example after we do this. Okay, so that's how you would describe it. For this, we're not going to describe this one. But for this one, it's very hard to talk about the shape of this. If your box is to one side or the other, you could assume that it's skewed. We do have an outlier, so you could definitely mention that. But it is very hard. That is the drawback of the box plot, is that it's very hard to talk about the shape. So you might not be able to, which is okay. You might even have to just say, I can't talk about the shape because it's a box plot. You could maybe look at, when you're doing your 5-number summary, what the mean is, and if they're very far apart, mean and median, you could maybe get to make a guess about it being skewed. All right, the last thing we need to talk about is one last graph, which is the Ogive. So this is talking about reading ability for children. They administered the test, they gathered some data. We want to construct a cumulative relative frequency plot, also known as Ogive. So relative frequency, remember, is a percent. So the Ogive is basically plotting percents. So this is what a frequency table actually looks like, except for you might have a column for tallies. It gives you classes, so ranges of what your data should be in. So this is going by tens. And then you're going to put the frequency here, how many are in each class. So ideally you would say, okay, I'm going to count all the ones 1 through 10 and like kind of mark them off. So it does take a little bit. We're not going to do that obviously because I don't want to take forever. I'm just going to give you what the frequencies are. And I believe these are correct, but if I make a mistake, you'll have to forgive me. So these are the frequencies in each class. To find our relative frequencies, remember that's a percent, so we've got to add these up and get a total. So there's 44 total, which, yeah, 44. All right, so then we divide to get our frequencies. So relative frequency is 0%. 6 out of 44 is 13.6%. I don't know why I did a decimal for this. You could round. This is, I'm going to round the rest of them. 21%, 30%. And these may not add up to 100 because I'm rounding. 27% and 9%. So this would actually be, we'll say 14%. All right, so that's our relative frequency. Cumulative frequency. So this is cumulative relative frequency. I don't know why they have this column in here because you don't need it necessarily to get your cumulative relative frequency, but we'll do it anyway. Cumulative frequency starts with the beginning frequency, but then it adds the next frequency each time. So it's cumulative as you go through the classes. So our next one is 6. 6 plus 0 is 6, so that's not very exciting. Then our next frequency is 9. 9 plus 6 is 15. Then our next one is 13. 13 plus 15 is 28. Then our next one, 12 plus 28 is 40. And then our last one, 40 plus 4 is 44. You should have 44. You should have here your number of data points. All right, so we should end up with 44, otherwise we added wrong. And this should end up with 100 if we did it right, unless we have a rounding error. So again, we do the same thing with the relative frequencies. You could potentially just divide these by 44 as well, either way. So 0, 14. 14 plus 21 is 35. 30 plus 35 is 65. 27 plus 65 is 92. Yeah, see, we're going to be off by 1. And then this is 101, but we'll say 100. I think this ends up being actually 91 if you use the decimals. And this is 90, or 64. This is 34. That's too... No, it doesn't end up being 100. I don't know, but whatever. You get the idea. So then how you plot an ogive. So this is what it would look like. Of course, you want to give it a title. So you'd say relative frequency reading or something like that. I don't know. Okay, an ogive always starts at 0, 0. Okay, always starts at 0, 0. And it should always go up as you're going through it. Your classes are going to give you where your next dot goes. We're going to use the second number of the class. So we're going to use 10, 20, 30, 40, 50, 60 to plot our dots. And you're going to plot the cumulative relative frequencies. So 10 is 0. Then we have 20 is 14. And these are decimals. So we got to do 0.14. So that's going to be, this is 0.1. So that's going to be in here. 35, so that is 0.35, so it's going to be in here. 65-ish, so that's going to be in here. And 91, 92, somewhere around there is going to be just right in here. And then you should always end up at 1 at the top, right? And then you connect the dots. And you don't have to make it look nice and curved. You can just draw straight lines, and I'm going to fail at that because I'm getting better with this, but it's really not very good. All right, so then you can answer some questions about this. What DRP score? So now percentile. Percentile is where, you know, if you're in the 90th percentile, I'm better than 90% of people who take this test. All right, what this means for this graph is your 20th percentile is 0.2 here. It's your cumulative relative frequency. So the 20th percentile, so if we want to know the score that corresponds to the 20th percentile, that's the cutoff for 20% of your data. You find 0.2 and you go over, and it's going to be probably like 23, we're going to say. 23, 24. All right, so we find this is going to be 0.2. All right, so what's the median? The median is 50%, so this is going to be 0.5. So we're going to find 50%, go down, so it's probably like 34. And then what's the IQR? The IQR is quartile 3 minus quartile 1. Quartile 3 and quartile 1 cut your data into fourths. So quartile 3 is 0.75 of the data because it's the furthest one. And quartile 1 is 0.25. The median is 0.5. So it splits it into fourths, 0.25, 0.5, and 0.75. So quartile 3 is the bigger one. So we need to find 0.75. So that's going to be probably like 42-ish. And then 0.25, this it's kind of a guessing game. I mean, yeah. And that's 25. And I'm really bad at subtracting. So let's see. It's one less and one less. So this is probably like, no, 17. Yeah, 17. All right, so that's going to be the IQR, is going to be 17. So you can use these graphs to find corresponding scores for percentiles, or you can say, okay, this is 20 is really like the 14th percentile, that sort of thing off of this graph. So that's how you get your percentiles. So that's it.